Let's start with the data. Data is the subject of computer processing and computation. Everything in a computer is expressed in binary strings of zeros and ones. Some of you have probably heard about this. Let's examine this a little closer by considering examples. The first example is numbers. Numbers have binary representations. Binary representations are nothing but binary strings, that is, string of zeros and ones. Characters can be also expressed as binary strings, in fact, in various different ways. For example, when expressing characters using coding scheme ASCII, the lowercase letters A, B, and C are respectively expressed as binary strings in this way. Viewing these binary strings as binary representations of numbers, A corresponds to 97 and B to 98, and so on. We will study this coding method later in this course. How about images? Here is a swallow, the logo of Tokyo Institute of Technology. Please remember it. This is a black and white image, but its jagged edges are visible if you look closely. It looks like this when enlarged. Let's apply graphing paper to it. Then there are black squares and white squares. Representing the parts made of black squares and white squares with ones and zeros allow us to represent black and white image. We just applied graph paper, thereby showing a way to express the image in binary. You can imagine digitalization as applying a graph paper in this way. Color images are often used in reality. We use a lot of picture elements to represent one color image on a computer. Picture elements are called pixels. A pixel contains tiny particles, red, green, and blue, called RGB. It is made of the thinnest grains that radiate each color. Those three grains form one pixel as a bunch. Various colors are produced depending on the degree of strength of the light. For example, this diagram is made of 30 vertical pixels and 30 horizontal pixels. That is, here are 30 by 30 picture elements. The total is 30 times 30, 900 pixels. Among ordinary PCs, many monitors and screens have 1280 times 800 pixels, for example, meaning 1280 horizontal and 800 vertical pixels. Digital cameras use pixels, but the idea is somewhat different, so we will omit it here. But they are used in essentially the same way. How about the sound? Sound is the waves from the density of air. Waves propagate sound. You can apply graph paper to these waves as well to digitalize them. Let's start by separating the quantity time with vertical lines. Then express the strength of wave density per time unit in numbers. That gives a number of strings. For example, 5, 7, 8, 6, 5 in this example. That is a quantized expression of sound in numbers. With actual digital sound, one sound is divided into 4,400 and 100 strips to quantize this sound. That's how numbers, characters, images, and sounds are represented in numbers. Finally, we can represent things by binary strings. We can represent images, and there is a recent research on representing smell and taste with zeros and ones. And the first step of computerization is to representing everything in strings of zeros and ones to make them subject to computation. To put it more simply, data is numbers, not strings of zeros and ones. To put it more precisely, consider them as natural numbers starting from 0. We just mentioned natural numbers can be represented in binary, so they correspond exactly to the strings of zeros and ones. Therefore, in the future in this course, in order to simplify things, please think of data as numbers in here.